Greetings! Let's go ahead and look at a parallel inductive circuit. In this circuit I have 5 volt peak-to-peak voltage source running at 7.5 kilohertz. My first inductor, L1, is 100 millihenries, and my second inductor, L2, is 10 millihenries. The first thing we want to do is go ahead and look at our totals. Our first total, V total, is going to be 5 volts. Our next total would be the total inductive value. Now, like resistors, we're going to go ahead and use the reciprocal formula, which is 1 over L1 plus 1 over L2. So we have 1 over 100 milli plus 1 over 10 milli. So I'm going to go ahead and put in the calculator 100 exponent negative 3, and then I'm going to go ahead and get the reciprocal, which is 10, plus 10 exponent negative 3, and I'll get its reciprocal, which is 100. Add them together, and I get 110. And now what I want to do is take care of that last reciprocal. So I'll hit the reciprocal key again, and I get a value of 9.09 millihenries. So let's go ahead and store this value in our calculator's memory. Next is inductive reactance. Inductive reactance is 2 times pi times F times LT. It gives us 2 times 3.14 times 7.5 K times 9.09 milli. So we have 2 times pi times 7.5 exponent 3 times, and we'll go ahead and recall our value. And what we have is 428.399 ohms. I'll go ahead and store this value in the calculator. Now we can find I total. I total is simply V total divided by the inductive reactance total of XLT. So we have 5 volts divided by 428.399. So we have 5 divided by our resistance that we saved earlier, and that gives us a current of 11.671 milliamps. Next, we can go ahead and find P total. So let's store this value. P total is simply I total times V total. So that's 11.671 milli times 5. So I'm going to go ahead and recall our current value and multiply it times 5. And we get 58.357 milliwatts. And that is all the totals for this particular circuit. Now that we've got the totals, we can go ahead and look at the individual values. And we'll start with L1. This is a parallel circuit and voltage remains the same. So VL1 is 5 volts. XL1, the inductive reactance of L1, is equal to 2 times pi times F times L1, or 2 times 3.14 times 7.5 K times 100 milli. So we have 2 times pi times 7.5 exponent 3 for K times 100 exponent negative 3, which is our milli. And we get a resistance of 4.712 K. Go ahead and store that value. Next we have current. Current is voltage of L1 divided by the inductive reactance of L1. So we have 5 volts divided by 4.712 K. So we're going to take 5 divided by, and go ahead and recall our resistance. And we have a current of 1.061 milliamps. Let's go ahead and store that value. Finally, we have the power of L1. The power of L1 is equal to IL1 times VL1. So 1.061 milli times 5. So go ahead and recall the value and multiply it times 5. And we have a power of 5.305 milliwatts. Let's go ahead and take a look at the second inductor. Of course, this is a parallel circuit, so voltage remains the same. So VL2 is 5 volts. Our next value is XL2, the inductive reactance of L2. And that is 2 times pi times F times L2. So we have 2 times 3.14 times 7.5 K times 10 milli. So we have 2 times pi times 7.5 exponent 3 times 10 exponent negative 3. And that gives us a resistance of 471.239 ohms. Put that in our memory. Next is current. The current of IL2 is VL2 divided by XL2. So we have 5 volts divided by 471.239. So 5 divided by, and I'll go ahead and recall my resistance. And that gives me a current of 10.61 milliamps. Finally, we have the power of 2. I'll go ahead and store this value. Power of 2 is IL2 times VL2. So we have 10.61 milli times 5. So I'll go ahead and recall my current and multiply it times 5. And we get is 53.052 milliwatts. So let's go ahead and check our values with Kirchhoff's current law. Kirchhoff's current law states that the current through L1 plus the current through L2 must equal the current total. So the current through L1 is 1.061 milliamps, and the current through L2 is 10.61 milliamps. So we're going to go ahead and recall the current of L1 plus, let's go ahead and recall the current of L2, and we have a total current of 11.671 milliamps. So we are correct. And that is a parallel inductor circuit.